Hello guys, we are continuing to study lectures belonging to the conservative department through the series of endodontic lectures. Now we are reaching another lecture about the intracanal instruments. This topic would focus on the most important intracanal instruments. It's quite important to focus and understand the basic principles behind this vital topic. Rotary instruments or rotary instrumentation systems using nickel titanium. So usually, most of the dentists they are going to use the profile system in their clinic. So when we talk about the profile or the system belong to this type, we need to know something relating to the history. So this profile system was launched into the market around 1994. So profile instruments have increased taperness compared with the conventional hand instruments. So if we look at this figure, we can see how the tapers increase it, and the cross section how it looks like the triangular one, and it has a better cutting efficiency in comparison to the conventional type of the file or reamer. So the types of the profile series 29 rotary instruments had a constant proportion of a diameter increasing 25 percentage. Cross section of the profile system has a U shape. Sometime if we look the whole cross section, it looks like this triangular one. If we take in a corner, so U shape would be detected well. So the design with radial lambdas and the parallel central core. So lateral view shows a 20-degree helix, angle constant pitch, bullet shape, non-cutting tip with a neutral or slightly negative rake angle. So in previous lecture belong to the type of the ungrouping of the files or the endodontic instruments. So we studied the positive and negative rake angle. You can review this important point again. So this configuration facilitates a reaming action. We also discussed about the difference between filing and reaming action. So in that case, this profile system facilitates helping us to do reaming action. Debris is transported coronally toward the crown part and is effectively removed from the root canal system. The preferred speed is 275 to 325 round per minute. Usually when you buy any sort of the file, you can find the information about the torque and the rounds per minute. So usually most of them it would be around 250 to 300 round per minute, but this type also mentioned 275 to 325 round per minute. So profile GT file, if we look, the greater taper file was introduced in 1994. This instrument also has a U-shaped file design. This instrument comes in 4 tapers like 006, 008, 001 and 012. The maximum diameter of the working part coronally is around 1 millimeter. Also, when we talked about the taperness of the file, if you remember, we studied a very nice slide about D1 to D16, how the diameter of the file would be increased from the tip to the most um, radicular part or throughout the working surface. The instruments have a variable pitch and an increasing number of roots in progression of the tip, the apical instrument diameter. So when we talk about the apical diameter, here 0.2 millimeter, instrument tips are non-cutting and rounded. If we look, this is non-cutting and it's not sharp one. It is non-active cutting end or non-active tip of the file. So also there is another type of pro-taper universal system. If we look at this one, the cross section is a little bit different in comparison to the other one. The pro-taper system is based on another concept and composite of 6 instruments, 3 shaping files. It means 3 files is specified for making the good shaping feature inside the root canal system, and the other 3 are finishing files, because we have shaping and finishing. When we talk about the pro taper or rotary files, we have to keep in our mind some specific files is designed for shaping and the other files are working on the finalizing or finishing the contour of the canal system. So this set is increased by 2 larger finishing files and a set designed for pre-treatment procedure. So when we need endodontic treatment, this set is quite helpful to be used in order to remove gutta percha and also reshaping of the canal system and refinishing again. In cross section, ProTaper shows a modified K-type file with sharp cutting edges and no radial lines. If you look, the tip is quite sharp, so it means that this one is designed for the cutting purpose, removing the dentinal wall through the intra-canal system. This creates a stable core and sufficient flexibility for the smaller files. The cross-section of finishing files F3, 4 and 5 is slightly relieved for increased flexibility. The difference in design of this system is varying tapers along the instrument's long axis. So the 3 shaping files have tapers that increase coronally, and also the reverse pattern is seen in the 5 finishing files. So shaping files number 1 and 2 have tip diameter of 0.185 and 0.2 millimeters respectively. 14 millimeter long cutting blades. The diameter of these files at D14 are 1.2 and 1.1 millimeter respectively. The finishing files, like from file 1 to file 5, means file 1, 2, 3, 4, 5 have tip diameters of 0.2, 0.25, 0.3, 0.4 and 0.5 millimeters respectively. Between D0 and D3, and the apical tapers are 0.07895 and 4 respectively. The finishing files have rounded non-cutting tips. So also here the files have non-cutting tips or end. The convex triangular cross-section of ProTaper instrument reduces the contact areas between the file and the dentin. So the greater cutting efficiency of this design has been improved by balancing the pitch and helix angle, preventing the instruments from threading into the canal system. Pro taper instruments can be used with 205 to 300 round per minute, so be careful. This is a very nice notification for the dentists. So usually in general, pro taper instrument files could be used or could be performed for using within the canal system with respect to the instructions for the round or speed per minute for every time rotation. So 250 to 300 round per minute would be a good speed during cleaning and shaping of the canal system. So it means that um, we can use the files effectively within the canal system around 200, and the speed shouldn't be more than 300 round per minute. Why? Because it causes a fatigue on the surface of the file, and later on when the fatigue property increases, then it causes what separation of the file within the canal system. So two usage characteristics are recommended for the pro taper system, like the preparation of a glide path. It means for every time when we change the file's patency, or the preparation of a glide path should be achieved well. The use of a more lateral brushing walking stroke, such a stroke allows the clinician to direct the larger file coronally away from danger zone and counteract any threading in effect. So RASA BioRace is another type of the file which was manufactured since 1999 by FKG manufacturer. The name stands for reamer with altering cutting edges. So this design aimed at reducing the tendency to thread the file into the root canal system. It means that the stress on the surface of the file would be reduced when we're using such kind of the file, and also the cutting efficacy could be obtained when the action of the file using like a reamer, inserting or pushing the file, then rotation according to the clockwise direction would be most appropriate usage of such kind of the file. So cross sections could provide like a triangular or square for number 002 instruments with the size 15 and 20 tips. The surface quality of raised instrument is done by electro polishing. So we already know that there is different surface treatment procedures. So one of the approach could be using the electro polishing. So the surface is polished, then different electrolyte is applied and seated on the surface. Then the efficacy of the file for the cutting property would be improved. The tips are round and non-cutting one. So if we look at the end of the file, is not cutting one, and it's just shaped for the helping the dentist to remove the debris, and they could be able to do good shaping within the canal system. So another one, it is a twisted file. So from the name of the file, the packing of the surface of the night tie could be compressed through a special technique, and the file looks like the twisted one. So the file in general is launched into the market and the dental suppliers provided for the dentist around 220. The first fluid nitrile file was introduced and manufactured by plastic deformation. It means that when the amount of the extra part is collected from the plastic one, then the plastic deformation could help the manufacturer to recycle this amount of the collected pieces and make such kind of the instrument or the tool. A process similar to the twisting process that is used to produce stainless steel K-file. This is done when a thermal process allows twisting during a phase transformation. I'm quite sure in the previous stages, like in second stage, you study something belong to the heating property in dental materials. So one of the phase transformation could be obtained like into the R phase of nickel titanium after some degree of the temperature. So when we're reaching this kind of the temperature, then twisting property of the material could be obtained. So the file based on the same scenario could be obtained through the manufacturing using the thermal compaction process. The instrument is available with the sizes like the 25 deep size only in taper with 0.04 and to 0.12 1. So this protection process resulted in superior physical property. When we talk about the physical properties, the some good properties like the maybe tolerating the forces of the fracture would be improved after using such kind of the heat generation and twisting the amount of the plastic deformation. So wave one single file reciprocating system also available in three different sizes like small, primary and large one. So if we look, when we talk about the wave one single file reciprocating small one, it means 25 length with the taper 0.06. When we talk about the primary, the color code is red one with the length of 25 and the taperness of 0.08, the black one color code, so the large one, so it could mean it means that the length would be 40 and the diameter, the taperness would be 0.08. The system is a single-use, single-file system to shape the root canal system. In most cases, the technique only requires one hand file followed by one single wave, one file to shape the canal completely using what kind of the motion? Reciprocating. The file is made with M-wire technology. There is a special technology could help the dentist to use such kind of the file for a long time, because the resistance is increased to cyclic fatigue about 4 times than the traditional rotary nitrile file. The system is composed of what? The wave one small file, this one exactly with the color code yellow one, it is used in a narrow canal. When we talk about wave one small size file, you have to keep in your mind that this file is designed for the narrow canal. So the length is 21, the taperness is 0.06. So the tip has an ISO of 20 with a continuous taper of 6%. The wave one primary file, when we talk about the primary one, the color code is a red one It is used in majority of the canals. So it means the medium size of the canal when we talk about the majority of the canals, because usually we have medium size of the canal. It is not quite narrow one and it is not quite wide one. So the medium one, the tip has an ISO of 25 with the apical taper of 8% that reduces towards the coronal end. It means towards the head of the file. So the wave one large one file, exactly the color code would be black one. It is used in wide canals. The tip has an ISO of 40 with an apical taper of 8% that reduces toward the coronal end. So the instruments are designed to work with a reverse cutting action anti-clockwise. So all instruments have a modified convex triangular cross-section at the tip end and a convex triangular cross-section at the coronal end. This design improves instrument flexibility. The variable pitch fluids along the length of the instrument improve safety. When we talk about the safety, is about the separation of the file within the canal system. Pro taper next. This system is composed of 5 files, namely like x1, x2, 3, 4, and 5.1. These files correspond to the size 20 with taper 0.4 and the size 25 with the taperness of 0.06 and the size 30 with taperness of 0.07, 40 with taperness of 0.06 and 50 with 0.06 respectively. The X1 and X2 have variable taper design, whereas X3 to X5 files have a fixed taper from D1 to D3. So you have to understand about these, how we divide it from the tip toward the shaft of the file, then a decreasing percentage taper design over the rest of the active portion, I mean the tip of the file. The system has a rectangular cross section. It means 4 corners of the cutting would be available during rotation process within the canal system. That is off-centered, which allows 2 points contacted with the dentin wall and the rest of the space free for storing debris, which will be removed by the file swaggering motion. Another group, engine driven or three-dimensionally adjusting file, self-adjusting file. So the cost of such kind of the file is a little bit expensive, but it is available in the market. Maybe some dental research unit, they provide such kind for their researchers. I think it is expensive if as individual dentists buy it and apply it for the patient. So the self-adjusting file presents a new approach in the design and mode of the operation. The file by itself also associate with the irrigation system. The file is a hollow device designed as a cylinder of thin-walled delicate nitrile lattice with a lightly abrasive surface. An initial glide path is established with the number 20K file to allow the insertion of the self-adjusting file system. So the file is proposed to be compressed from it is 1.5 millimeter diameter into the dimensions equivalent to those of a number 25K file. The handpiece generates in and out vibrations with 5000 vibration per minute and 0.4 millimeter amplitude. The compressed file will adapt itself to the root canal walls, applying a uniform cutting action, gradually removing a uniform dentin layer from the canal walls. There are continuous flow of irrigantes which removes the tissue debris and the dentin powder generated by the file. So it means that when we are going to use self adjusting file, the irrigation system automatically associate with this system and removing the possible accumulated of the debris that may pack within the canal system. So driven reciprocating instrument and the reciprocating files, the gyromatic handpiece, a rotary instrument in use since 1969. So it is a simple history about how such kind of the instrument available and launched into the market. So it delivers 3000 quarter turn reciprocating movement per minute. So it is too fast in 1 minute. Rasps and braided brooches are most often used in gyromatic handpieces, but K-type and headstrom H-type instruments also can be used as well. The Indo-Z file system Ultradent is a recently introduced addition for gyromatic handpiece. The set has 4 instruments that are designed to clean the middle third of the canal. So when we want to clean the middle third of the canal system, then driven reciprocating instrument the best one to be used. The sizes and the tapers are 0.1 number 0025 taper, 0.13 number 0.35 taper, and 0.13 number 0.45 taper, and 0.13 number 0.06 taper. The use of stainless steel hand instruments is suggested for the apical third of the canal system. So, sonic and ultrasonic instruments. It is quite important for dentists to use sonic and ultrasonic instruments because there are too many advantages, like the activation of the irrigation solution within the canal system, especially if we want to clean the apical third. Usually we need to do vibration, so some ultrasonic instruments could help us to vibrate the irrigation solution in that specific area with respecting of the working length when we insert the tip of the instrument within the canal system. Sometimes the ultrasonics could help us to remove the debris as well, and also opening the canal system when the polypstone exists. So it's quite important how to use this kind of the instrument and tools during endodontic and therapy. A very different way of instrumenting root canals was introduced when files or ultrasonic tips of different shapes and sizes were activated by electromagnetic ultrasonic energy. Piezoelectric ultrasonic units are also available for this purpose. These units activate on an oscillating, it means like circulating sinusoidal wave in the file with a frequency of about 30 kilohertz. Um, Two types of units, ultrasonic and sonic, are primarily available. Ultrasonic devices which operate at 25 to 30 kilohertz include the magnetostrictive Cavi Indo and the piezoelectric ENAC, and sonic devices operate at 2 to 3 kilohertz sonic AM150. Ultrasonic devices use regular type of instruments, for example K-files, whereas sonic devices use special instruments known as Rispi-sonic, Shaper-sonic, Triasonic, or Heavy-sonic files. By the way, different resources or different textbooks may mention different type of the sonic and ultrasonic activities. For example, the frequency of the ultrasonic instrument, usually from the frequency point of view, it gives around 4 hertz, 40 hertz, and the other one is around 20. So although similar in function, piezoelectric units have some advantages over the magnetostrictive systems. For example, piezoelectric devices generate little heat, so no cooling is needed for the electric handpiece. The magnetostrictive system generates considerable heat, and a special cooling system is needed in addition to the irrigation system for the root canal. The file in an ultrasonic device vibrates in a sinus wave like fashion. A standing wave has areas with maximal displacement, that's to say antinodes, and areas with no displacement, that's to say nodes. The tip of the instrument exhibits an antinode. Files must be used only for a short time, must remain passive within the canal, and the power must be controlled carefully. So when we are using ultrasonics, we have to use with a good caution and short period of time, and don't manipulate the instrument within the canal system too much, because the tip of the file may damage the walls, and sometimes it may cause ledge formation. So when we are inserting the tip of the ultrasonic tool or machine into the canal system, we have to respect the instructions that provided by the manufacturer how to handle the machine and using within the canal system. Ultrasonic devices have proven very efficient for irrigation root canal systems. So usually ultrasonic devices could help us to reach, for example, if we want to remove the debris from the apical thread by a side vented needle, we could not be able to clean thoroughly the canal system. But if we want to clean the apical thread, also the efficacy of the ultrasonics would be quite helpful in order to remove the debris within the canal system. So during free ultrasonic vibration in a fluid, two significant physical properties and effectiveness are observed: cavitation and acoustic streaming. During oscillation, it means when it simply rotates in a fluid, a positive pressure is followed by a negative pressure, causing implosion. This is cavitation. Acoustic streaming creates a small, intense circular fluid movement around the instrument. So, by positive negative pressure, when you go through push and pull, so at least you can make some oscillation of the fluid in that or the solution around the apical third. And when we inserted the ultrasonic within the canal system, some sort of acoustic streaming could be very intense, and the movement of the fluid around the instrument could be found. So this is the end of the today's lecture. So if you have any concern or if you have any question, then you can pass your questions to the representative if it is quite urgent, or you can write down your questions on a piece of the paper. When we have next lecture, we can negotiate. Hope you can read the lecture smoothly and understand visibly. Have a good time and good luck.